Hello, ma'am.
Hello, JABIN. Good morning.
Yeah.
Yeah, sorry for the late, JABIN.
Yeah.
Thank you. So we were discussing mensuration, right, in the last class? And we discussed about, so far we have discussed about rectangle, square, triangle, and circle.
Yeah. Square and triangle.
Yes.
Yes. Yes.
Okay. So today we'll discuss something new. Okay. Like trapezium and what else?
Wait. What is a trapezium exactly? I know what it is, but I don't know the actual shape of it.
Yeah, I'll show you. I'll show you.
I don't really remember the actual shape.
No worries. I'll show you. Share the screen. First, I'll show you the diagram and then I'll explain what is trapezium. Okay. So these are trapezium. Can you see the diagrams in the left-hand side? It's a quadrilateral.
Oh, okay.
It's a quadrilateral and it having two parallel sides of unequal length, and other two sides are non-parallel. I'll show you how. Over here, you'll be able to notice this side and this side. They are parallel, isn't it? These two lines will never intersect each other. They'll never meet. These two lines are
so you'll never meet.
They'll never meet.
Never meet.
And if you look at the bottom and the top, they are unequal in length, isn't it? They are unequal.
Yeah. Unequal, yes.
The top one is smaller than the bottom one. Yeah. So
trapeziums are things like they never touch each other, and they don't have equal space.
Equal lengths, exactly.
Yeah.
Similarly, if you look at these two sides, let's take the left hand side and right hand side. They are non-parallel. Non-parallel. They are not parallel.
Over here. Yeah, ma'am.
Yes.
Yeah. Over here it says not trapezium, right? So why is this not a trapezium? It doesn't have equal length.
It doesn't have equal length, but the thing is they are not parallel. They are not parallel lines. The top line and the bottom line are not parallel to each other.
They're required to be parallel.
Yes. One set is parallel and one set can be non-parallel.
But this one also is not parallel.
Which one?
Is not parallel.
It is. I'll show you how. That is parallel. I'll show you how. This line and this line. These two lines are parallel lines. Can you see it? You would be able to see an equal spacing between them. Like over here.
But they don't look equal.
They don't look equal. They're tilted for certain angle. They are tilted. But if you draw a line, these two lines are parallel.
Oh, okay. Now I get it. Yes. Yes,
So
ma'am.
I'll show you the examples of parallel lines. First, let's learn about the parallel lines. Then you'll have a clarity. Parallel lines. Okay. Can you see it? Can we call
Yes,
these two lines as parallel lines?
Yeah.
Yeah. Okay. And
They have
we can
distance.
also call these two lines as parallel lines. They are not horizontal.
Yes.
They are not horizontal.
Yeah.
They are not vertical, but you can call them as parallel lines. You'll be able to notice equal spacing between the lines. You're getting it?
Wait, on the picture over here, is this one parallel lines? Wait, can you go back?
Yeah.
Yeah, or the picture over here, is this a parallel line?
This one. No, they're not parallel. See over here, this spacing, let's assume this is like 3 or something. This looks like greater than 3, isn't it? Like let's assume this is 4 centimeter or something. This is greater than this. Yes?
Yeah.
This is not parallel.
I thought it would be parallel because they won't be touching each other.
They won't be touching each other. Like they can be non-parallel also. The lines can be non-parallel also.
Okay.
The one thing is like they do not intersect at any point. They do not touch each other. But the thing is they will maintain the same distance between them. Between these two lines, they will keep a fixed distance.
Yeah. Yes.
All right. So if you look at these, the left and right, they are parallel to each other. But over here, you'll be able to observe a triangle over here. It is not a trapezium. Like here, what happens? These two lines intersect at one point, isn't it?
Yeah.
You'll be able to notice a triangle.
Wait, so
Combination of
they should be.
Yeah.
Okay. So for trapezium, the requirement is like you must have parallel lines, right?
Yeah. You must have parallel lines and non-parallel sides also. Non-parallel sides also.
Okay.
Both. Like
wait, over here, these are parallel sides. Then how come this one then
these one are not parallel, isn't it? Like let me use the word left and right. The left side and right side, they are parallel to each other. But if you look at the top and bottom, in the top you have a line, but there is no line in the bottom.
Okay, I got it.
There is no line in the bottom.
Yeah, I got it now.
So you need 4 lines, okay? Like top, bottom, left and right. Understood?
Okay. Understood.
Okay. I will show you some types of trapezoids also.
Okay.
Okay, let's learn that. Okay. JABIN, I want you to draw this one.
My notebook?
I want you to note down. I want you to draw this in your notebook. Yes. And draw this as the example for trapezium and draw this as the example for not trapezium. Can you do that? Yeah.
Which one? Which one
This
for
one.
not
Can you see it?
trapezium?
The purple one. The purple one is for not
Okay.
trapezium.
Yeah.
Yes.
Done. Ma'am, I am done. Ma'am, 1 minute. Ma'am, done.
Done, Jabin?
Ma'am, what's the difference of trapezoids and trapeziums? Hello?
Hello. Yes, Jabin?
Yeah. What's the difference of trapezoids and trapezium?
They are same.
Oh.
They are same. They just spelled in, they spell different in different countries. That's it. In US English, they call it as trapezoid. In UK English, they call it as trapezium. Both are same. Let me write it. They are same actually. They just spell different. Excuse me. In US, they call it as trapezoid. And according to UK English, they call it as trapezium. Got it?
It's just the same.
Yeah, it's just the same. They just spell different in different countries. That's it. Okay. So shall we learn about the types of trapezium?
Yeah. Yes, ma'am.
Just a second. I'll show you the image. Yeah. Yeah. Can you see this? Can you see the screen? Can you see the screen? Yeah. So types of trapezoid.
Yeah.
So you can classify them into two categories. One is based on size and another one is based on angles. Okay. Please note it down.
What should I write? What should I write?
So based on size. Based on size, you have scalene trapezoid and isosceles trapezoids.
Sides. Wait, 1 minute.
So in scalene trapezoids, no sides are equal. You take all the four sides. 1, 2, 3, 4. No sides equal.
Wait, 1 minute. Scalene trapezoid.
I'll give you some measurements too. I'll give you some measurements also. Like let's assume this is 2 centimeter and this is 2.5 centimeter.
Should I draw the diagram?
Yeah, I want you to draw the diagram also. So it's 2, 3, 2.5 and 4 centimeter. All the four sides are different. They're not equal.
Isosceles trapezoid. Okay, I'm done the
First
based on
one.
sides part.
Scaling.
Wait, I forgot to draw the diagram for isosceles.
Put the heading as scaling and draw. And also note down the notes as no sides are equal.
Yeah,
You're done?
I'll do it for both.
Okay. The next thing, isosceles trapezoid. In isosceles trapezoid, two sides are equal. The side AB and side DC are equal. Like if you take this as 3 centimeter.
Your voice is breaking.
My voice is breaking. Yes, I can hear you clearly. Is it breaking now also?
No, now it's not.
No, it's fine. Okay. So I was explaining about the isosceles trapezoid. In isosceles trapezoid, two sides will be equal and two sides will be not equal. Okay. So the two equal sides are nothing but AB and CD. Okay. They are equal. Like this side and this side, they are equal. In a sense, if AB is 3 centimeter, the DC is also 3 centimeter. Understood? AB is 3 centimeter means DC is also 3 centimeter. Okay. AD and BC would be different. Like assume AD is 4 centimeter and BC would be 6 centimeter. This is isosceles. Two sides will be equal and two sides will be unequal.
Okay.
So put the heading as isosceles trapezoid, draw the diagram along with the measurements.
കഴിച്ചോ ഇരുന്നില്ലേ 3 മണിക്ക്
Yeah.
You're done?
Yes.
You're done noting it down?
Yeah.
Show it to the screen. Show it in the screen, the isosceles trapezoid.
Yeah. I was already done. I drew both of the diagrams. I was already
Just a sec.
done.
Where are the measurements?
Oh. Six. Okay, done.
Okay. So these two categories are based on sides. Let's discuss about the angles. Okay. So the angle you can call the pink trapezoid. Can you see the pink one?
Yeah.
So that is based on angles. Okay. So this trapezoid is based on angle. And here they are saying two adjacent angles are acute. In the sense, these two angles, the angle B and angle C. Can you see it? Two angles are lies in the same line, isn't it? The angle B and angle C fall in the same line. Okay. So these two angles can be called as adjacent angles.
Oh, wait. Wait. 1 minute.
Yeah.
There's an acute angle here.
Yeah. What do you mean by acute angle?
The
Yeah,
one that
over
is
here.
less than 90 degrees.
Very good. So acute angle is something which is lesser than 90 degree. So what they're saying is here you do have an acute angle which is B, and here the angle C is also an acute angle. The angle B and angle C both are acute. Okay. So when you have two adjacent angles as
for acute trapezoid,
yeah.
For acute trapezoid, you have to have two adjacent angles.
Angles, yeah. And it should be acute.
Oh, okay.
Understood?
Yes.
And obtuse is also very simple, which is greater than 90 degree. Two angles must be obtuse, but here they are not adjacent, they are opposite to each other. The two opposite angles must be obtuse.
So, like example, there is one shape. Okay. Suppose there is one shape. Okay.
Okay.
So, okay. Wait.
Yeah, you're right. You're right. You give undo. It was perfect. Yeah. So this angle is obtuse angle, isn't it? It is greater than 90 degree. And similarly over here also it is obtuse.
It has to be opposite.
Degree. It has to be opposite, exactly.
So example, yeah. Ma'am, example, it is over here. Will it also be opposite to here?
That's acute. That's lesser than 90. That's lesser than 90. See, the 90 is here.
Yeah.
It is smaller than 90. The one which you drew before, that's correct.
Yeah, I was just saying if it was over here, if there was an obtuse angle over here, then it would be opposite.
Yeah. Yeah, it's perfect. And the last one is right trapezoid. Okay. So it's right. Two adjacent right angles. So here you'll be able to notice right angle which is drawn as a small square. Can you see it here? The A is 90 and B is also 90.
Yes.
And they lie in the same line.
Yeah.
They are lying in the same line, isn't it? So two adjacent right angles must be two adjacent angles must be right angle. Understood? Draw the diagram. Draw all the 5 diagrams. Put the heading as acute and draw the pink one. Put the heading as obtuse and draw the yellow one. And put the heading as right trapezoid and do the green one. Please note it down. I'll just come back in a second, Jabin.
Okay.
You're done, Jabin? Okay. Can you quickly explain me what and all we have discussed? Can you explain it from your notebook?
We've done trapezoids.
Yeah.
In that, in order to get a trapezoid, it must be parallel to each other. The lines should be parallel to each other.
Yeah.
With equal distance.
Yeah.
Then we learned about scalene trapezoid,
Yeah.
which and isosceles trapezoid,
Yeah.
which is all based on sides.
Yes.
Then we learn acute trapezoid, obtuse trapezoid, and right trapezoid, which all are based on angles.
Yes.
Yeah.
Is that from you?
Wait, let me write the obtuse.
Done?
Wait, man.
I want you to share a song for a trapezium. No, you don't have to find anything. I'm saying I'll share a song on trapezoid.
Wait, before you share it, can I first copy the track?
You need to copy what? This thing? The dice?
Yeah.
Yes,
Yeah.
yes, you can do it. No problem. Take your time.
And one more shape.
Yeah, no issues. Just let me know when you're done.
Okay. Okay, I'm done.
Jibin, are you done? Okay, dear. Shall I share the song now?
Yeah.
Okay. Can you see the screen?
Yes, I can.
This is kind of kindergarten song only, but it is just to entertain you.
Everybody knows what it means to be
Yeah, I can hear.
a wreck.
Can you hear it?
Yeah, I can hear it.
All right.
Everybody knows what it means to be you. A rectangle, 4 sides, 4 corners to view. They know the qualities of my many-shaped brothers, but no one knows who I am, not like these others.
Don't be so sad, my friend. You should have pride. They will fall fast for you once they have tried.
Cone is a party hat, cube can play dice.
But you've got 4 sides to you. I think that's nice.
Cylinder is a can, ready to drink.
You're a great popcorn box. That's what I think. Be proud, my trapezoid. You're a rowboat. 1 pair of parallels, but you can float.
I'm not like your square, but I'm a jewel. I am a trapezoid, different and cool.
For more songs, games, and original.
That's it. Do you like it?
Yes.
Okay. Okay. I hope you had some idea about the trapezoid. Let's learn new 2D shape. Let's learn about the rhombus. Do you have any idea about rhombus?
Isn't it just like square? Square.
Okay.
Sorry.
Yeah, no problem. You just
yeah,
tell me what you
square.
know about it.
It looks like it kind of like a stretch square.
Stretched square.
It's like
yes.
a diamond or a diamond.
Yes.
Yeah. That's all it.
Okay, can you give me some real-time examples, like where you have observed this rhombus shape?
Diamonds.
Diamonds.
I think that's all.
That's all. Okay. Any other food items or something? Any crackers, biscuits?
Crackers, yeah. Crackers,
Yeah.
sometimes they have the shape.
Yeah.
Yeah, I think that's all. I think that's all.
Just a second. Can I call this as a rhombus?
Yeah, you can.
Yes. Can you draw a rhombus from your Zoom screen? Can you draw it? There is an icon like where you can choose the exact shape. Okay. You have a rhombus over there. Try it and do it in the red color or black color.
Should I do the same as yours or how?
Yeah, anything. It's your wish. Any size. Just choose some different color. Yeah. Yeah, that's nice.
Yes.
Okay. So now let's learn what is rhombus. Okay.
A rhombus is
You
like,
already told me
call
it's a...
this a rhombus?
Yeah, we can call.
Can we?
You can.
But
But
actually, you can make it into a cube like this.
I think it's stretched. It's stretched. Far. You have to tilt a little. You can call rhombus as a tilted square. It will hold the square property.
Yeah.
Because
like
all the 4 sides needs to be equal. That is the only thing. Yeah.
The stretch rhombus can also form a cube.
Yeah, you can. Yeah, by extending it. But here the rhombus is in 2D shape. What you have drawn just now is 3D.
Yes, ma'am.
Yes. So to be a rhombus, what it takes to be a rhombus. 4 sides are equal, okay? All the 4 sides should be equal. What you have drawn is fine. Only this part is rhombus, okay?
Yeah.
This is 2D,
Yeah.
this is rhombus. And if this side is 4 centimeter, this is also 4, this is also 4, this is also 4. All the 4 sides are equal. Understood, dear?
Yeah.
So to be a rhombus, rhombus has all 4 sides equal, just like a square, but the thing is, it's a tilted square.
Yeah. It's not like straight. It's not straight.
Because this is square, isn't it?
Yeah.
It's rotated to certain angle to be a rhombus.
Yeah, I think 45 degrees.
Yeah, diagonally we are rotating. Yes, you can say it is 45. Yes.
Okay.
The diamond, the example you gave me for rhombus, it's a very good example because this shape resembles a diamond. Okay.
Yeah.
And have you ever seen cards? Cards,
Yeah.
with playing cards. You can call that as rhombus.
Oh, cards. Yeah.
Yeah. And have you ever played with kites?
Oh, yeah.
Have you ever
kites
played
do
with
have-
kites? Yeah.
They do have. Yeah.
Yeah. Kites. And some crystals maybe. Okay.
Yeah.
So let me note down the properties of rhombus. I want you to draw the rhombus and note down these things underneath. Okay. Rhombus has 4.
Okay, ma'am.
Please note it down. Has 4 straight equal length side. I hope my handwriting is clear. Equal length
Yes,
sides.
ma'am. It is.
And it has 4 vertices. What do you mean by
What's up?
vertices, JABIN? Can you
Yeah.
show me in the diagram? Can you draw it and show
Is
me?
it like the wait? Are these vertices?
Yeah. Yeah, exactly.
Okay.
Exactly. Very good.
So it's just same as a vortex,
Yeah.
but just a different word.
This is just in the plural form. Same.
Okay.
And 2 lines of symmetry.
Okay.
And if you look at the angles, present inside the rhombus, you'll be able to notice 2 acute and 2 obtuse angles.
Okay.
2 acute and 2 obtuse angles. And yes, they do have 2 pairs of parallel lines. 2 pairs. I will show you parallel lines.
Yeah, they do it. They do have options.
Yeah.
2 options.
That's nice.
And 2
Like for example, I'll try to differentiate. Like you can call this pair as parallel, and the red ones are parallel. Similarly, let me do it in the green. The green, they are also parallel to each other. So there are 2 pairs of parallel lines. You can otherwise call them as 2 lines of symmetry. Understood?
Yeah.
Okay. Can you, I'll give you an activity. Can you create a kite out of a paper or card, something for a rhombus shape?
Right now?
Not now, like you can submit it before Wednesday.
Okay.
Okay, please note it down. I want you to make a kite. And that kite should hold all these properties, and it should have all the lines should be equal in length, and two pairs of parallel lines, two acute angles, and two obtuse angles. Okay.
Okay.
I want you to create a rhombus kite. If you want, you can shade them in different color. It's totally up to your creativity.
Yeah. Rhombus kite with all the rhombus. Wait, ma'am, I have a question.
Yes.
Like, is there always two acute angles and two obtuse angles
Yeah.
at every like a rhombus, every type of rhombus?
Exactly.
Oh, okay. So like these types, let me use it. Okay. So these ones, I don't think so. They have.
It does. It does. The top and bottom has acute, the left and right has obtuse. Can you see it? Let me mark it. Please allow me to mark. Let me mark acute angle in a red color. These two, the top and bottom, they are acute. They are lesser than 90 degrees, isn't it?
Oh,
Like this
okay,
is
okay. I
obtuse.
understand now.
You can tilt the square to any angle, but you will be ended up having the same two acute angles and two obtuse angles to be a rhombus.
How about this one?
And that also.
But doesn't look. It looks like a straight angle.
It looks
right
like a square, but the
right.
thing is you need to tilt a bit. You need to tilt a bit because in square what happens? In square what happens? You will be having right angles in all the four corners, isn't it? Like you will have 90 degree, 90 degree, 90 degree over there. So you can't say it has two acute angles and two obtuse angles. All the four angles must be right angle to be a square. That is the only difference. You will tilt a little in rhombus. You will stretch a little.
Okay. Yeah, I got it.
Okay, dear. I'll give you a formula for a area of a rhombus and area of a trapezoid. Okay. I want you to note it down. Area of a trapezoid or trapezium, anything. And area of a rhombus. To make B. Okay, here. It's 1/2 times D1 into D2. I'll show you what is the D1 and D2. I'll show you what is D1 and D2. D1 and D2 are nothing but diagonals, okay? So here the diagonal lines are from here to here.
Those are diagonals?
Excuse me, sorry. So these two lines are diagonals.
Oh, okay. So those
I'll show you what are diagonals. Let's assume this is diagonal 1 the diagonal line 1, and this is diagonal line 2, D2. I'll write the spelling. It's DIAGONA, diagonal. Diagonals, plural.
Okay. Yeah. Yeah, I copied Rhombus.
Yeah. So you asked me what are diagonals. Okay. I'll give you an explanation about diagonals. A diagonal line is a straight line. Okay. It's a straight line that joins two corners of a polygon. You take any polygon, you take any shape that join two corners and it goes through middle of the shape. Okay. It goes through middle of the shape. Can you see it? It goes through middle of the shape. Can we see it? It connects these two corners, isn't it? The left and right.
Yeah, yes.
And similarly, you take this. It passes through middle of the shape. And of course, it does connect both the corners. Please note down the explanation for diagonal line. Diagonal line joins two corners of a polygon, or any shape, and it goes through middle of a shape. Understood, Jabin?
Yes.
These lines are diagonal lines. Okay, I'll give you a formula for trapezoid also. With that, we'll wind up the session. Area of a trapezoid. I'll teach you about this area concept in the next class. Okay, so area of the trapezoid is 1/2 times height times sum of the parallel sides. Sum of the
It's almost the same of it's almost same as
rhombus, but it has height over
triangle.
here. It has
No,
height.
I mean triangle.
Like half into base into height, you're saying?
half into base into height. Yeah, it's almost the same.
You do multiply base, but here you have to add the parallel sides. Okay. For example, like let's assume the word height as h variable and sum of parallel sides is like a plus b. So this is the formula. I'll show you in the diagram. Let's take this side as a and the bottom side as b. Okay. So you need to add their length. You need to add their parallel sides. The top line and the bottom line, they are parallel to each other, isn't it? So you have to add them. And height. What is height? Here, this perpendicular line. This pink line is height.
Okay.
That is height.
Yeah, 1 minute, ma'am.
Yeah. Excuse me.
Okay, I'm done.
Note down the formulae with the diagram. For trapezoid.
Yeah, I'm done. Yeah, I'm done.
You're done? Okay.
Yeah, I'm done.
Do you have any doubt in today's session, JB? You're clear?
No, ma'am.
Okay then. Okay then, JB. We'll stop here.
Yeah.
Bye-bye, JB. Have a happy weekend.